This is Srikanth, working as assistant professor in electrical department. In this video, I want to discuss about basic problem on our electrical circuits. So for every problem, we require some formulas, some logic. Okay, so in exams or in different exams, we have different circuits. For each circuit, we have different logic. For each logic, we have different formulas. Okay, so for every problem, we require some formulas and logic. We'll check it now first. Here we have like a Ohms law. So for Ohms law, I is directly proportional to V. From this formula, we'll get like V value as well as I value and R value. So V equal to I into R, and so V equal to I into R. If suppose I want like I value, V by R. If suppose I want R value, V by I. So this is a Ohms law triangle. And same thing, okay, if you want like P value, okay, so P value, V into I square R, and V square. If suppose in exam, so one voltage source, one resistor. Okay, I have a voltage source and one resistor. So V is like a 10 volts and R is suppose like a 2 ohms. Then find out the P value. So for that we can find out directly. So V square by R will get like P value. Otherwise I have like a current value and resistor. So I have a current value I, suppose 2 amps, and resistor like 4 ohms. Then I want to find out the power. So use I square R formula. Okay, and I have the P value and R value. Just find out the I value. Then root of P square. So root of P by R. Okay, so anything depending upon the examiner. So if you have like any two value, you can find out the remaining values using these formulas V, I and P and as well as resistor. Okay, this is from Ohm's law. And coming to your current and voltage relationship in passive elements. So for resistor, inductor and capacitor, we have the formulas. So V equal to I into R and I equal to V by R from Ohm's law. And same thing we have like V equal to L di by dt and I equal to 1 by L V dt, integral V dt. And same thing here, capacitor 1 by C integral I dt and I equal to dV by C into dV by dt. So for inductor, you store the energy in form of current. For capacitor, stores the energy in form of voltage. So for single wire, any conductor, the resistivity formula is rho L by A. Resistor formula is rho L by A. Same thing, inductance formula is mu and n square. So number of turns squares into area by length. That is your inductance formula. And capacitor formula is epsilon naught. A is area and D is the distance between two plates. So that is a capacitor formula. And energy stored in the inductor is 1 by 2. So half Li square, and same thing 1 by 2 Cv square. So these are the formulas. If suppose I have like I have L value, some L is like a 2 Henry and current is 2 amps. Just find out the energy stored in your inductor. Then use 1 by 2 Li square formula and get the answer. Okay, and suppose I have like number of turns value and the area value and length value. Just find out the inductance value, means use this formula. So in anything, suppose I have the L value and A value and length value, just find out the number of turns. Okay, so any one value you want to find out, means you can use those formulas for inductor as well as capacitor and resistor also. Okay, for capacitor, the stored energy 1 by 2 CV square. So store the energy in form of voltage. So 1 by 2 CV square. Here 1 by 2 Li square. Here current, here voltage. So this is like small basic formulas. If you know the one value, if you know the unknown values, one unknown value, you can find out using these formulas. Okay, any one value. Suppose here I have like a area and capacitor value, you can find out the distance also, how much distance those plates are there. Okay, and here also, if you have like a current value in separate some time, so in particular time I have the current value, and what's the voltage in inductor means, if you have the inductor and current value means you can find out the voltage value. Same thing here, if you have the current value, if I want the capacitor value in separate time, what is the voltage drop means, what is the voltage we have means, we can find out the capacitor value also. So these are like basic formulas. These are basic formula for any circuit. Okay, now we have moving to the AC. For AC we have some different formulas. For AC, any periodic wave we have like sine wave. Okay, for sine wave, for what is the peak value, what is the peak to peak value, what is the like time period, okay, what is the time period, and what is the wavelength. So everything we have in one wave. Same thing, we have the different periodic waves: sine wave, square wave, triangular wave, sawtooth, okay, complex networks. So we have different periodic waves we have. For each periodic wave, I will find out the values. So each periodic wave, I will find out the some RMS value, form factor, peak factor, average value, RMS value. So we have different values, unknown values. So for that, with the formulas for average value 1 by t. So any periodic wave. So any periodic wave, we have a formula. So 1 by t, 0 to t, f of t dt, and same thing RMS value. So root mean square. So any meter, if I measure any meter, there's voltage or current. So we can measure in any meter. So for every meter, we can see only RMS value, not average value, not real value, not peak value. Okay. So for sine wave, we have the positive peak and negative peak. So in particular time, for this time we have the negative value. In meter, we can see like negative values. We have like RMS values for any meter. Okay. Now for RMS 1 by 2 integral 0 to t and f of t square dt. So here we have the average, and you can remember like this root. So root mean square. RMS means root mean square. So root is root. Okay. Mean means your f of t square. Root mean square, that is your RMS value. You can remember like this also for formula. If you know the average formula, you get the RMS value formula. And form factor, peak factor. So why this form factor, peak factor means, so particular waveform, we have a different waveform. So particular waveform, when you compare with another waveform. So for that purpose, you can require like a form factor and peak factor. So for each waveform, we have different form factor and peak factor. The formulas for form factor, RMS value by, so which value we have the RMS value by your average value, that is your form factor. Peak factor is peak value, which peak we have. So this is your peak value. So this peak value by your RMS value. Okay. So form factor and peak factor. So form factor is RMS value by average value. Peak factor is peak value by RMS value. So these are the like formulas for some different periodic waves. So here we have some problems on those formulas. Here, if suppose I have one resistor and one more like a voltage source resistor, as well as one more resistor. Okay, and I have like a I value and V value. So I want to find out the power. So for that we have a P equal to V into I. That is a simple one. Okay. If suppose I want to like find out the R value, R equivalent value. So I don't like R1 value, R2 value, but I can find out the R equivalent value. So for that we have V by I. So in general, in any exam, so he given like n number of resistors in series or parallel or star to delta, delta to star transformation. So anything he given in different manner. But at last I want to find out the current value. Okay. So for that I want to find out the equivalent value for this resistors I. Then I have the R equivalent. Then I want to find out the V by R equal to your current value. Same manner, if I don't know like R value, but I know the voltage value. So this is my circuit. same circuit. So here I have like a n number of resistors connected in series or parallel or any other manner. So here I have the I value. Here I have the I value and I have the V value. So I want to find out the equivalent resistance means you can go for directly V by I. Power also, if you want equal to V into I. So you can use like basic formula, I can find out those R values. Okay, use just logic and find out those values. And suppose I have an inductor stores in form of current, so I have the current value some 2 amps. Okay, and find out the energy. So for inductor is 2 Henry, then your energy formula is 1 by 2 L I square. So for capacitor 1 by 2 CV square. So don't confuse, guys. So which formula you required for which problem? So use that formula and get the answer. And coming to periodic waves, I have like sine wave. I have sine wave. For this sine wave, I want to find out the form factor, peak factor, as well as RMS average values. So for form factor, peak factor means RMS by average, and peak factor is peak by RMS. So for that I require like RMS value and average value. So any sine wave, just we have the time periods pi, 2 pi, and 0. We have some peak, suppose Vm. Okay, this is a time period, and this is V of t. For any sine wave, if you want to find out the average or RMS, so one rule we have for average. So suppose this peak is Vm and this is the minus Vm. If you get the average means positive peak value and negative peak values, we'll get like 0. So for average, your time period is only, you can consider only positive peak. No need to go for like full time period. Generally, this sine wave time period is 0 to 2 pi. So for this sine wave, your time period is 0 to 2 pi. That is your time period. But for average, you need to consider time period is only pi. For RMS, you can consider like 2 pi value. No need to worry about that total time period. So Y means RMS. We can go for like full time period. Coming to average, we need to check it like which waveform we have. If you have the positive peak and negative peak, both are same, then we will go for the only half. Otherwise, you can go up to here also, no problem for RMS. So which value we have? Same value. So up to this, which average you will get, same average you will get up to here also. So you can consider average time period is pi by 2 also. So any time period you can consider. Here pi by 2 or pi. Y means, so 0 to pi by 2, which average we have. So which average we have, same pi by 2 to pi, same average we have. So we can consider up to this. That is enough for sine wave. And just substitute those values. For substituting those values, 1 by t for average. So V average, the formula is 1 by t integral 0 to t f of t dt. But I know the t values, time period for average. So you can consider like pi or 1 by pi. So pi by 2. But what about f of t? F of t is nothing but your equation. This sine wave, what is the equation? That is Vm sine theta or Vm sine omega t. You can use like any formula. So we have like Vm sine theta. So Vm is your peak value and sine theta. So for this sine wave, if suppose I have like square wave. So positive peak and negative peak. Same peaks we have. So like Vm and minus Vm. Then we can consider up to here. Then what is the equation for this? So we know the time period. Time period is okay. Which value we have, we can consider that value. And what about like the equation for sine wave? It's a straight line. It's not depending upon time. For sine square wave is not depending upon time. But your sine wave is depending upon different. So different timing have different peaks. But coming to square wave, 0 to pi has time, your value is constant. So for this square wave, we have the Vm value. Coming to triangular, for triangular, we have positive peak as well as negative peak, or positive peak also no problem. Okay, so for this, which average we have, you can consider up to pi by 2 also same average. Okay, so 0 to pi by 2 slope. So we have like a slope. So go for the slope equation, that is like y minus y1 by y2 minus y1. Same thing we can consider like a y minus y1 by y2 minus y1. Same here we have like x minus x1 by x2 minus x1. So use simple basic formula and get the slope equation. From the slope equation, consider here f of t. Replace the f of t is your slope equation, and the time period. Time period you can consider like for average is different, for RMS is different. And what is the RMS formula? That is same, 1 by t f of integral f of t dt. That is your average value. Now root and mean square. So that is your RMS value. Okay. So this is our square, sine wave, and triangular. If so, my wave is half wave. So this is my half and now. So what is your time period? So my time period is 0, pi and 2 pi. So what is your time period 0 to pi? No, your time period is 0 to 2 pi. Why 2 pi? So waveform started here. Again, waveform started here. So again in this x-axis, so my waveform started again at 2 pi. So my total time period is 2 pi. That is your time period. Then what about RMS and average time period? So in previous case I said like when you have the positive peak and negative peak, if you go for the average means you will get the 0. So for this case, we need to consider like total time period. So we don't have any negative peak, but we have like positive peak. Suppose here I have like a 0, 1, 2, 3, 4 and 5. So 0, 1, 2, 3, 4, 5 numbers. I want to go for the average. So I have 0, 1, 2, 3, 4, 5. So I have total 6 numbers. I want to go for the average means 1 plus 2 plus 3 plus 4 plus 5 by 5. No, it's wrong. How many numbers we have? 6 numbers. So you can consider 0 plus 1 plus 2 plus 3 plus 4 plus 5 by 6. Okay, this is your average. Same thing here. I want to consider the 0. Here my peak is 0. So I need to consider this peak 0 value also. But 2 equation we get. So 0 to pi I have one equation, and pi to 2 pi I have one equation. So 0 to pi, that is your f of t. So here v of t is Vm sine theta. Coming to pi to 2 pi I have like 0. Pi to 2 pi it's 0 peak. There is no value. So your average value. Your average is 1 by t. T is 2 pi integral 0 to pi. I have Vm sine theta plus pi to 2 pi. I have 0 value. So 0 means no need to consider. Okay. So from this we'll get the average. Same thing. RMS also we have the same time period. Okay. That is about half wave. Coming to full wave. So square or sine, same thing. Okay. For full wave, what is your time period? Again, you need to consider up to pi only. So my waveform started here, again started here for this x-axis. Okay. So 0 to pi is your time period for average and RMS. For average and RMS we have the same value. Okay. And here I have one more complex network. If you observe this complex network, about same problem I discussed in my previous videos. If you observe, okay, here I have like a waveform. So started 0, pi by 3, 2 pi by 3 and pi, some different timings, and peak is suppose Vm. Okay, if suppose now my waveform is this is, here we have only positive peaks. Okay, but here I have the positive peak and negative peak. If you compare both, okay, so for this type of problems, we will get the same answer. For this type of problem, average and RMS, same thing here, average and RMS. Same answer is get same answer. So we will get the same answer from both different problems. So positive peak and negative peak we have for this circuit. For this circuit, we have only positive peak. Okay, so no need to worry about that positive and negative peaks. So I want to find out the average and RMS values. For average, if you observe both values, so for average, here positive peak and negative peak. So what is your time period? Up to here, up to positive peak only my time period. Same thing here, up to this my time period. Okay, time period is as it is. So which value you have same VM here and same VM peak we have. Now my time period 0 to pi. 0 to pi is your time period for average. Same thing here, 0 to 4 is your average. 4 is nothing but pi. So no need to worry about the time period. Okay, so I want to find out the average and RMS. Now if suppose I want to find out up to 2 also, up to here. So which average we have, same average here. So which average we have, same average here. You can consider up to here also will get the same answer. So no need to worry about that. So if you want to consider only positive peak means we have the positive peak time period. Okay. So how many equations will you get? So for this we have 0 to 1, one equation, and 1 to 3 I have second equation, and 3 to 4 I have third equation. Same thing here, 0 to 3 by 1 pi by 3 I have one equation, 2 equation and 3 equation. Here increasing slope, same increasing slope, and here's constant, here constant and decreasing slope. So decreasing slope. Same. We get the same answer. So we have 0 to pi by 3 have an equation, pi by 3 to 2 pi by 3 have an equation, and 2 pi by 3 to pi I have one equation for this wave. Same thing here, 3 time periods. Okay. So in general we have 3 time periods. For this equation, for this waveform we have phi t. So it's increasing. Use the slope formula and get the f of t, like v of t value. And for this time period we have like a straight line. And for this time period we have like phi into 4 minus t from the slope form. So we have 3 equations. Same thing if we for this we have phi pi by 3, and for this phi means like a Vm. If suppose here phi means phi, Vm equal to phi means we will the phi. Otherwise Vm means Vm into pi by 3, and here straight line for square wave. It's a square wave means here we will get like Vm. So we have like Vm. Again decreasing slope, we will get the slope form. So this is about like different time periods. We have the different equations. For each equation we will write the values. So for average, suppose average 1 by t is your, so here pi means that is your pi. Here 4 means that is your 4. Okay. Integral 0 to 1. First 0 to 1 I have increasing slope. So here 0 to pi by 3. 1 or pi by 3 same. Time period no average value and RMS value or any value. So form factor, peak factor, it's not depending upon your time. The waveform will be changed. So time period will change the values. But in general, the RMS and average values will depend upon your peak values. Okay. Now 0 to 1 I have like a, for this waveform phi t. Here suppose the Vm is pi. Vm is phi. So phi t and plus 1, 2, 3, which value we have? That is phi dt, here also dt, and last 3 to 4, which value we have? Phi into 4 minus t. But your total time period is 1 by 4. But 0 to 1 we have different equation, 1 to 3 have different equation, 3 to 4 have different equation. So if you solve this equation, we have the answer. So this is about like square wave, so not only square wave, triangular wave also we have, triangular, square, and sine wave also is same different answer. Okay. Now coming to one more concept, that is rectangular to polar and polar to rectangular. So polar, so for each, so for AC circuit we have real value and imaginary value. So for admittance and impedance, so we have an impedance, that is a Z value, when we have the R as well as L. So resistor and inductor. For AC circuit, we have the resistive value and inductor value. Suppose both are connected in series, I want to add both values. Then I require polar to rectangle, rectangle polar logic. So R is in ohms, but your L is not in ohms, it's a Henry. So for that, I want to convert into ohms. That is inductive reactance. So we can add resistor and reactance. And when you are adding both values, we have like one impedance. In that impedance, we have the real value and imaginary value. So we have, so suppose this is impedance, my impedance value. For this impedance value, we have the real value and imaginary value. So there is one triangle. For this triangle, we have the real value and imaginary value. So J values. So a particular J. So here suppose this angle is suppose plus value. Suppose my value is minus value. So we'll get like here minus value. So here if suppose between 180 and 90, I have different angles. For this I have real value is different and imaginary value also different. So each places your theta value as well as your real value and imaginary value is depend. Now I have like impedance values, real value and your imaginary. You can assume like otherwise Z equal to R plus J XL. XL is inductive reactance. If suppose, okay. Now I want to convert this value like which value we have, Z equal to R plus J XL value. Just convert into polar form. So general polar form is in angle. So impedance, suppose your impedance is real value with your angle value, plus or minus your angle value. Now I want real value. So if suppose your X is your R value, Y is your XL value, then if I find the real value means, so from the triangle we'll get like R value. R is root of X square plus Y square. Otherwise you can write like from this R value. So Z in R I require, this R value is nothing but root of R square plus XL square. Angle with theta. Theta is, for this angle I want to find out means tan inverse XL by R. So XL by R. Tan inverse XL by R equal to your theta value. Okay. So like that we can find out the polar form. So why this nonsense? Why I need to find out the polar and rectangle polar? So why means if suppose I have two impedance. So Z1 and Z2. So Z1 is 2 plus JXL. So J3. And Z2 is 3 plus J5. Now I want to add both values. So we're going to add means, so we have the real values. We're going to add like Z3 equal to, so 5 plus J3 plus 5, we have 8. So we can add easily. If suppose I want to multiply both values. So Z1 into Z2. I want to multiply both values. Then how it is possible? So for this I want go to polar form to rectangle form. So for that polar form means we have like R1 angle with theta. So here R1 angle with theta 1 and R2 angle with theta 2. Now you can multiply both. So R1 theta 1 into R2 theta 2. So for this, so both are in multiple position. So real value multiple position means R1 into R2. And here theta is angle position. So here we have small condition. When theta 1 and theta 2 both are in multiple position, then we can add. So both are in multiple position, your theta equal to theta 1 plus theta 2. If suppose theta 1 is divided by angle 2. So then the equivalent theta is theta 1 minus theta 2. So we are multiple position. So we have a equivalent value theta 1 plus theta 2. So when the two impedance is division position, we have like R1 angle with theta 1 by R2 angle with theta 2. So then your equivalent value is R will get, so when divided R will get, then theta 1 minus theta 2 is your real value. Okay, so some logic when we can convert, so when we are required the impedance value in division position or multiplication position or addition position or subtraction position. So these are the small formulas to solve those equations. So that is rectangular to polar, so rectangular to polar and polar to rectangular. So these are main important when you are doing the AC circuits. So this is very important to solve those circuits. Coming to like series parallel, so when you have the series impedance or parallel impedance, then what is the equivalent value? So for that I require the values, that is inductive reactance and capacitive reactance. So for inductive, if I know the L value, if I find the XL value is 2 pi L, that is your XL value. Same thing, if I know the C value, I want to find the XL value, XC value is 1 by 2 pi FC. So in exam, so I have like inductive value is L and resistor value is suppose 2 ohm, L is 3 Henry. If suppose, then I want to find out the equivalent value, that is impedance value. So for that, I know the L value, but I don't. My formula is when two like resistor and inductor, so resistive and inductive both are connected in series, then my equivalent value is R plus JXL. So R plus JXL. And when you have resistive and capacitive both are in series, means R minus JX, R minus JXC, and 3 are connected in series, then we have the R plus JXL minus XC. Now 3 are connected in parallel, then we have the formula is Y equal to, so impedance means Z, then what about Y? Y is your reverse, impedance reverse, that is admittance. So Y is your admittance, 1 by Z. So 1 by Z is your admittance value. Now for when the resistor, inductor, capacitor 3 are connected in series, then we have a formula. But now they are connected in parallel, then my formula is G, again G. What is the G? G means conductance, that is 1 by R. So which value has the R? That is 1 by R plus again BC. Again what is the BC? B means your susceptance, so reverse of your reactance. Which value you have like inductive reactance and capacitive reactance. So 1 by C, BC is nothing but your 1 by XC, BL is nothing but 1 by XL, and here we have XL minus XC. In general, when the impedance like RLC in series means we have XL minus XC. Coming to parallel means 1 by XC minus 1 by XL. We have the J value. So J up means we have the plus value. So minus in going up means we have plus value. Same thing, J here with the minus value, we will get the minus. Don't forget the J value. We have the J in XL and XC, we have the J values. So we have the plus and minus. So for BC plus and BL, we have the minus. This is your rectangular form. We convert into polar, rectangular form, convert into polar, rectangular form, convert into polar, rectangular form, convert into polar. So these are the small formulas for AC circuits. And we have one more topic, that is power. So for power, so mainly we can say like 3 types of powers we have. That is a real power, reactive power, and apparent power. And you can say like complex power also. So mod up your apparent power. So why 3 means, so for real power means which power you can utilize. So which power you can, in general in your home we have like every month we are paying bills. That bills is depending upon your real power. And reactive power means wasting the power. So we're not utilizing that power. Where you have the inductive and capacitive loads, there you have the reactive power. That reactive power you can't utilize. That waste the energy in form of like a heat or in form of any other manner. So storing the energy in form of inductor is stored in the form of current, and capacitor is stored in the form of voltage. So some voltage is storing in that place and some energy is lost. That energy is your reactive power, and your active power you are utilizing that power. And you can say like your apparent power is VI cos theta and VI sin theta. That is your reactive power. This is your real power. So this is your real power and this is your reactive power. And real power units is kilowatts. So you can see in your bills also. In your bill we have some units, that units in form of kilowatts. Okay, and reactive power units is kVAR. kVAR. And we have one more small topic, that is form factor. So for every electrical equipments or electronic equipments, we have this form factor value or cos pi value. You can observe in your home. We have some electrical equipments is observed in your home. We have like cos pi. They will give like 0.9 or 0.85 or 0.95 like this. Not 1. So actually, if you have the power factor 1 means the equipment is resistive load. So for resistive load, the power factor is unity. Coming to capacitor load, for capacitor load, the power factor is leading, and inductive load, it's a lagging. For inductive load, it's a lagging power factor. For capacitor, it's a leading power factor. Okay, so those are like power factors, and the formula is active power by apparent power. So here I have small problem. One supply, AC supply I have R, L and C. So 3 are connected in series. So R value I have, L value I have, C value I have, and V value I have. Now I want to find out the power value. Simple circuit. I want to find out the power value. So in general, P equal to V by I. So V into I. P equal to V into I. Now I want like a V value. So I have the V value. I want to find out the I value. So I don't have any I. Otherwise you can use like P equal to P squared by R. You can use this formula also, no problem. You can use any formula. Okay. So I know the V value, but I know the R value. What is R here? So for DC circuit we have the R value. But AC circuit we have impedance value. For AC circuit we have impedance value. So for impedance value, here R, L, C, 3 are connected in series. So what is your impedance value? Your impedance value is R plus J XL minus XC. XL minus XC. So I know the R value. I don't know XL and XC. Again, L you can convert into XL value. That is 1 for L XL value, that is 2 pi FL. So I know the 2 pi value, but what is the frequency? For frequency, in exam he given any frequency, no problem. Otherwise you can consider like 50 Hz. For India we have the 50 Hz frequency. So F value we know and L value we know. Just substitute those values and find out the XL value. Same as XC value. XC value is 1 by 2 pi FC, and find out the XC value. We know the F value, we know the C value. Find out the XC value and substitute those XL and XC value, and you will get the Z value in of R, J, X. So J plus X. R plus JX will get. Now from this Z you can find out the P value. So P equal to V squared by Z. So we know the V value. V angle we have already have the angle V squared by your Z value. Otherwise, I want to find the current value, that is V by I. So V by Z. So what is the V value? We know the V value, angle 0, and your impedance. Impedance is in rectangular form. So R plus JX form. So you can convert into V angle 0 as well as R angle with some theta. So for R plus JX, we will convert into R value. So R is nothing but root of R square plus X square. Otherwise you can use the calci. So in calci we have the steps to find out those values. So for these types of calcis, shift then plus. So shift plus, then press the plus value. We have the polar. We can convert into rectangular polar. If suppose I want to convert into polar to rectangular, then again shift minus. We will get the rectangle values. Okay. So I want to convert into polar. So shift plus, which value we have? Suppose R is 2 and X is suppose 3. So 2 again comma. So 2 comma means again shift here with the comma, close brackets. So we will get the comma. Then 3. So polar, then that means shift to plus 2 comma 3. Again close the bracket, then enter. We have r value and as well as theta values. Both values will get r as well as theta. Okay, same thing rectangle polar. If suppose I know the r angle is some, so r is 4 angle with 45 degrees. 4 angle with 45 degrees. So I have again shift rectangular. So shift to minus 4 comma 45. So then I have values x and y values. That means real and imaginary values. So real value here 2.8 and plus 2.8 j 2.8. Okay, so this is about like a rectangular polar and current as well as voltage for the given circuit, AC circuits. Okay, when the series means what is the formula and what is the parallel means what is the formula. So this is about logic as well as formulas and basics electrical circuits. So any electrical circuit are FW or BW. So we have the basics, formulas and AC as well as DC. And next video I want to discuss about like a mesh analysis, nodal analysis, star to delta, current division rule, voltage division rule, Kirchhoff's laws, and basic formulas, super node, super mesh, basic formula and logic, which logic we have to solve those circuits. Okay, thank you for watching. Keep watching my videos.
Like, share and subscribe. Hit the bell icon for more updates.